Hi, this question is from the practice exam 2022. So you see the two blocks A and B, they are tied with a string, a lightweight rope, and we are applying a constant force F0, a constant force continuously. So right now as well. Okay. So I have shown you the two diagrams. In the first diagram, the block A has not crossed the point B. In a second diagram, the block A has crossed the point B and now it is moving on a frictionless surface. But remember that the point B is the block B is still moving on a rough surface. So in this question, we have to compare the tension in a string which is applied r- on the block A in this direction and on the block B in this direction. So if the tension is T before the block A cross the point B, will this tension increase or decrease? Conceptually speaking, the tension should increase. Why? The reason is when it will transition on a smooth surface, so the acceleration of the system will increase. So this is the direction of acceleration. But I will find out mathematical derivation also. Please stick to the video. So this acceleration will increase. When acceleration will increase, the stretchness between at the two ends will increase, which means that the tension is increased. Okay, because tension is always due to stretching of the rope. Okay, so the block A will pull the block B with a more force. Okay, because overall, right now, so so let's find out the acceleration. And right now, I am saying that the acceleration of the system is A1 because I will compare the tension on the based on the acceleration. So let's say it's A1. Okay. So you if we apply the Newton's second law, so A1 must be equals to the F net, the resultant force, sum of all forces divided by the all the masses, right? Which means that the both masses MA plus MB, since they are identical, so you can say just 2m. Now, what is the resultant force? Right now, the resultant force is F0. It's a constant force, it's our applied force, and minus, don't you think there is a frictional force exerted on A as well as on B in this direction? There's a frictional force, right? So I will say it is F0 minus mu mg minus. So it's better to write just F because they have not mentioned any coefficient of friction. So let's say it is just F minus F because both of the frictional forces are opposing the F0 divided by the 2m. So this is the acceleration. A1 is equals to F0 over 2m minus 2F over, so it can be written as like this. So this is acceleration. If you're wondering that why is there's a no tension in this equation, then the reason is that the tension is an internal force which has been cancelled on the two ends. So this is acceleration. Now what is acceleration in this case? Now the A2 will be equals to, once again, the sum of all forces divided by sum of all masses, which is m plus m. Now dear students, at that point there is a no friction on the block A, but there's a still frictional force exerted on the block B. So when we will write equation, so we would say F0 minus F over 2m. So you see that the A2 is equals to F0 over 2m minus F over 2m. That's exactly what I told you, that acceleration will increase, and you see that it has been increased. So let us see that what is the value of the tension. So the tension T minus frictional force, I'm applying Newton's second law, is equals to ma1, right? So the tension T must be equals to ma1 plus frictional force, and if I put the value of the acceleration, so it is f0 over 2m minus f over m plus f, right? So what is it's going to become? It is going to become f0 over 2 minus f plus f, right? So it is cancelled out, right? So what is that value of tension T? So the value of the tension T is equals to F0 over 2. Now we will compare it. So tension, this is the new tension, let's say T prime. So T prime minus F is equals to ma2, because now the system's acceleration is different. Okay, so the T prime is equals to the frictional force plus ma2. So simply just put the value of the acceleration here. So if you open the bracket, so it will become f0 over 2 plus, sorry, minus f over 2. So you can now compare easily that how the tension T prime has been changed. So it is F0 over 2 plus frictional force divided by 2. So this is a new tension, whereas this is a old amount, like the original tension. So don't you think the new tension has been increased by an amount of F over 2? So that's why the right answer should be B, tension increases.